let's talk with Boeing engineer, Mr. Alec Herzog, who's a member of the Professional American Institute of Aeronautics and Astronautics. That's a mouthful right there.
Yes, it is.
I imagine that takes a lot to get involved with there.
It does,
place.
yes. A lot of work.
So, Mr. Herzog, thank you so much for being here. You are an aerospace engineer.
That's right.
Which we were talking before. That sounds way fancy. So tell me what that is, and also talk a little bit about what engineering is anyway.
Sure. So I'll start with some background on myself. So I went to Parks College of St. Louis University. That's SLU, just near downtown, not too far from here. And this picture I have up here is a picture of the building that I went to class in just about every day. And we got this retired airplane in front here, and that's because that's the building where you learn how to be an aerospace engineer.
Wow, you have an airplane at your school?
That's right.
That is really neat.
So if you kind of break down aerospace engineering, if you look at it in two parts, talk about aero, so having to do with the atmosphere. That means I can solve problems that have to do with the atmosphere. So I learn how to design vehicles like I'm showing here. So airplanes, helicopters, UAVs, unmanned aerial vehicles, oftentimes called drones.
Wow.
That's really the aero part of the degree.
You design a drone? I just flew one of those the other day. It's really cool.
Yeah, we work on them all the way down from the ones you can buy in Walmart all the way up to the ones the military flies, like I'm showing here.
So, okay, so you design stuff like that. That's really cool.
So that's really the aero side of the degree. And then there's the space side of the degree, which is solving problems that have to do with above the atmosphere. And that means I learned how to design vehicles like rockets and satellites. And really the best part of the degree is knowing both those things and being able to leverage them means I could work on stuff like the space shuttle, which actually takes off like a rocket but lands like an airplane.
Oh, wow, okay.
So after graduating from school, I went to work at Boeing. That's where I work now. I worked on two projects since I've been there. The first is the F/A-18, that's on the left there. And that is really the primary jet for the U.S. Navy. So it takes off and lands on aircraft carriers around the world.
That seems like you'd have to have a really good plane to land while something's moving in the ocean like that.
Yes, it's a very capable aircraft.
You have to be very careful when you design those kind of things, huh?
That's right. So now the program I work on after moving off that is the Boeing TX, which I'm showing in the bottom right. But that is a contract that we just won, and that's going to be the next training jet for the U.S. Air Force. So all the pilots coming through the Air Force in the future, this will be the first jet that they sit in when they learn how to fly airplanes. So that's a little bit about what I do now, but I can move on to talking about what is an engineer.
Sure. What's an engineer?
So really an engineer is anyone who's asking how and why do things work. Asking how and why things work is how you find the problems in the world and then think up solutions to them. Mm-hmm. Really though, a professional engineer, someone who is working as an engineer, who's been trained as an engineer, what they really are is a real life problem solver. And real life is really the key adjective there because real life problems are not like the problems that you do in school. Mm-hmm. Real life problems, they don't have answers in the back of the book. They're complicated. When you come up with a solution to a real life problem, there isn't a teacher sitting there at the end that's going to tell you how well you did with your solution. And so there's just an infinite number of real life problems out there in the world, and it's unrealistic to think that just one person could learn how to solve them all. So really there's a lot of different engineering disciplines that have been made in order to tackle all these problems.
Okay.
And so I'll go through just some of them. There's
Sure.
too many to count, but we talked a little bit about aerospace engineering, so solving problems in space and in the air. There's also mechanical engineers, so guys that learn how to solve problems with mechanics. They would be the people that, for instance, design and develop cars or work on planes' landing gear. There's software engineers. You'll find them throughout the industry because they solve problems by developing code. Same with electrical engineers. They're all throughout the industries because they solve problems developing circuitry, which is in pretty much everything today. You have civil engineers who have learned how to design and build structurally sound buildings and city infrastructure. Environmental engineers know how to solve problems having to do with preserving Earth and optimizing its resources. Chemical engineers, you'll find them again throughout the world. They're people that do things like develop the fuel that goes into our vehicles. And there's even agricultural engineers, so people that solve problems having to do with farming, like how to better plant and harvest crops.
I had no idea there were so many of them.
Yeah, pretty much the way it's going nowadays. If you can think of a problem, there's probably an engineering that's been made to tackle that problem.
Okay.
And so they all seem very different. They're all trained in different ways, but they share a couple things in common. One of the things that they share in common is that when they solve a problem, they follow this general engineering process. And it's the same process that these kids worked with in Miss Bloomer's class when they were designing their rockets and their spacesuits and rovers and stuff. So when an engineer so this process is what an engineer uses to solve a problem no matter what. It doesn't matter if it's going to take a day, a week, a month, or years. This same process, we use it every single time. And so when we first get the problem, we have to look at the problem, we have to ask and research the problem. So we have to know how big the problem is, what are the constraints, what other problems relate to this problem, things like that. Once we think we know everything we need to know about the problem, we just start imagining things. Anything that comes to mind, we write it down, we draw it up until we have as many solutions that we can think of. And then we move on to the planning phase. So we take one solution that we think is going to be successful, and we choose that to go forward with. And we make that decision based on our knowledge of math and science and what we know has worked in the past and what we know hasn't worked in the past. So we go through the planning phase, we make some really detailed drawings so that we can then build a prototype of the thing that we have in mind. And that's a really important step because oftentimes when you're working with your hands and you're building something, you find that you might have missed something in the design. And so when you move on to the testing phase, you can find out if the thing you maybe missed is really going to be a problem or if you can get by without fixing it. This is also the time in the testing phase where you can find out if the thing is really going to work like you designed it to work. And if it's not working, you take that as feedback. You go through the process as many times as you need to until in the end, you have a solution that solves your problem.
There's so much creativity that's involved in that.
Oh yeah, definitely. I would say that is one of the #1 traits of engineers. Is very, very creative to be able to.
How do you how do you just imagine stuff? Is there something that you, as a process, you go through to help you imagine things?
I think it's different for everybody. I think one of the things it's also kind of unrealistic that just one person is going to have all these great ideas, and so oftentimes we work in teams so that you have the ideas of everybody around you to come up with these ideas.
So teamwork is also important.
Yeah, teamwork in engineering is very important. And it's really important that each engineer in the team has collaboration and communication skills. If they don't, then their ideas aren't correctly communicated to their teammates, and the solution might not be able to solve the problem you were setting out to solve.
Oh, interesting. Well, we do have a student question for you, if
Okay,
you don't mind.
sure.
So a student wrote in, and they would like to know that what got you interested in aerospace engineering?
What got me interested?
Because there's so many different ones you could have chosen, as we just learned.
I would say that when I was a kid, I used to always love going to pick up family and friends from the airport. I used to always want my parents to get there super early so I could sit in the cell phone lot and watch the planes take off and land and wonder what they were doing. Actually, when I was going into school, though, I was a pretty avid golfer. I still am. And I actually was toying with the idea about using my degree to develop golf balls originally.
Oh.
So,
Like different kind of golf balls?
Yeah.
Like
yeah.
different shapes and sizes?
That's right.
Wow.
So that's
all
not
right.
exactly how it worked out. I went with planes, but there's a lot of different stuff you can do with the degree. So.
Good for you. Another student has another question for you.
Okay.
What are the characteristics you think are most important to be a successful engineer?
I would say 2 really important characteristics are integrity and work ethic. Oftentimes when someone comes to an engineer with a problem, it takes integrity to admit that you don't have the best solution to the problem right off the bat. You're going to need to go research and do the work to come up with a solution, and then you need that work ethic to actually go out there and do that. So I would say those are 2 really important characteristics.